Alright, 29. Let's see, a bag of 100 tulip bulbs purchased from a nursery contains 40 red, 35 yellow, and 25 purple. Remember, over half the battle is just reading the problem and figuring out where do I start. What's the probability that a randomly selected tulip bulb is red? So probability of red. Well, how many are red? We got 40 out of 100, which is 40%. Probability that it's purple. Well, we got 25 purple out of 100, or 25%, which is of course 0.25. Interpret these two probabilities. Well, that just means I have a 25% chance of randomly grabbing a purple and 40% chance of randomly grabbing a red one. Alright, 31. Roulette. Let's see here. Oops. Game of roulette, 38 slots around the wheel. There's also two green ones, a 0, and there's a double 0 behind there that you can't see on opposite sides. To play the game, a metal ball is spun around here, and then it drops into one of the spots and slots and just hangs there. To play the game, it's allowed to fall into one of the numbered slots. Determine the sample space. Well, the sample space is, well, as it's written there, 0, 0, 0, and then it starts with the numbers 1, 2, 3, all the way up to 36. Okay, what's the probability the metal ball falls into the slot marked 8? The probability that it gets an 8 is 1 out of 36. 38, because there's 38 spots. Okay, so that means you have a 1 in 38 chance of winning if you put your money on the number 8. Okay, C. That's B. C. Determine the probability that the metal ball lands in an odd slot. Interpret the probability. Probability it's odd. Well, how many numbers are odd? Well, exactly half of those numbers, so that would be half of 36 is 18 out of 38, which if you divide by 2 is 9 out of 19. So the probability that it's odd is 9 out of 19, so you have a 9 out of 19 chance, whatever percent that is. So a percent is easier to understand, so 9 divided by 19 is 47.4. See, that puts it in the house favor instead of 50%. You have a 47% chance of winning if you bet on odd. Alright, and 35. College survey conducted by the Centers for Disease Control to determine college health risk behaviors. Colleges ask, how often do you wear seatbelts when riding a car driven by someone else? Frequencies appear. I totaled this up. Save a little bit of time. Construct a probability model for seatbelt use. Okay, so X, so that'd be seatbelt use. And this is the probability of little x. So we have never, rarely, sometimes, most of the time, always. And of course, a probability is a percentage or a decimal. And since there's 4776, rarely is 125 divided by 4776 is, and I'll write this as a decimal point 026. Rarely 324 divided by 4776 0.068. 552 divided by 4776 0.116. So these people, not only are you am I questioning your judgment on not wearing a seatbelt, but in addition, you're not wearing a seatbelt and trusting someone else driving. Go figure. 1, 1257 divided by 4776, 0.263, because being a statistician kind of guy or statistics kind of guy, how much do seatbelts, what do they do to save your lives in an accident? Well, that's why they're the law. 0.527. There's your editorial while we do the problem. So there's a probability model. Would you consider it unusual to find a college student who never wears a seatbelt when riding in a car driven by someone else? Is this unusual? 2.6%. The answer is yeah, I consider it unusual. It's less than 5%. 5% is kind of the general cutoff, depending on what the situation is. But if something that happens 2.6% of the time happens, then I'd be like, yeah, that's pretty rare. All right, 44 I'm going to do on a different video.